The utopia of many large organizations is a development approach which effectively takes whatever the business and the stakeholder envisions and transform it into the perfect product. This means delivering on time, within budget, and answering to the market and the business needs. Whatever that will be, a new wind turbine design, a new aerospace solution, or just a clever way to manufacture a new type of product. Producing and designing these systems is not a trivial task. Why is this so difficult? And how do we go about solving this issue? That's what we'll dig into in this video.
There are many frameworks and methods for how you, as a project manager and designer, can go about bringing an idea into the real world. You have probably heard about a few of these design and project management approaches, whether that is PMI, Scrum, the Waterfall model, or Prince2. These frameworks provide a structured and well-described approach to managing projects. Now, I want to be clear. All of these are good approaches with their pros and cons. But when you start to investigate further, you will probably run into more questions as to which approach to use and also which part of them to apply in your project. Generally speaking, it is not uncommon that the amount of theory can be just as overwhelming and complex as the project itself. And it does not make it any more easy that there are plenty of software providers which want to facilitate these methods. We know that the last thing a busy designer or project manager needs is to read up on even more information or rely on advanced software solutions to hopefully save the project. That's why we want to go through the basics of a design approach called systems engineering and explain how you, as a project manager, can use this to handle the complexity of your project, and hopefully doing so without overloading you with theory. In these videos, we want to give you a more hands-on approach for how to be in control of a design through the systems engineering methods. Our goal here is to 1. Teach you the basics so you can go about implementing these approaches where you do not have to rely on specific software solutions. The only tools you will need here are a pen and a piece of paper, although of course software is always handy. 2. A practical approach with examples for doing this so you will know where to start and how to move forward with your daily tasks. And 3. Lastly, this is the high-level fly-in, so you have the confidence to show overview and clarity in your project. But why even choose systems engineering? Well, systems engineering as such is by no means a new approach to designing systems. It has been used to put men on the moon, build vast infrastructure projects, but is also used to control the design of basic equipment in, for example, manufacturing. Systems engineering is mainly used where many technical specialists have to speak together to create a design which in of itself is too complex to be handled by a single person. It is a way to handle complex systems by dividing them into manageable chunks, while still allowing the freedom to find the optimal choice within a solution space. One of the weaknesses of systems engineering is the amount of theory and knowledge condensed in it, which can seem overwhelming. There are quickly a good amount of technical terms you can encounter. These are of course important, but we want you to forget about those for a while and focus on the basics first. Then we will build on top of that. Systems engineering is by no means a one-size-fits-all, but in our approach, we will aim to capture the most essential in our 3 introduction videos and make it practical for you as an everyday usage. System architecture. We'll go through how to create the initial system architecture and explain what a system architecture is. We'll go through how to use this as the basic way to navigate and communicate current system design to specialists and stakeholders. Maturing system and requirements. Here we will take you through how to handle requirements and continuously mature them as the design progresses. And system integration monitoring. When the system architecture is in place, we can start enriching it by utilizing a structured approach to map and track how the subsystems interact and influence each other.
If you would like to know more about our approach to systems engineering and how we have applied it practically, please take a look at the description below. Otherwise, I hope to see you in the next video.